Hey, I'm Natalie. I am scientist with heart. You can be a brilliant scientist and still you can lose the students during a lecture. You can lose their attention, you can lose their interest. Mostly it has to do with these 5 common teaching mistakes that you find often with beginners, but also you find them with more experienced educators. So if you are a beginner educator, PhD student, or postdoc that starts their academic journey and has teaching duties, maybe this is something for you. These 5 common mistakes that we now discuss might help you as a new educator to get started a little bit more smoothly. And if you avoid them and fix them right from the get-go, your life will be much easier, nicer, and you will have happy students because they actually reach their learning goals. The 5 common mistakes are: number 1, too much content, overloaded slides, too much information. We've all been there ourselves during our studies. There were lectures that were really interesting. There were a lot of slides, a lot of information. We got the PowerPoint slides. We had the passages in the textbook, chapters. But it was just too much. It was all over the place. And in the end, we left the lecture and thought, oof, what was this all about? It was so much. And then one can remember one thing, the other second thing, the third colleague can remember something totally different. And at home, you have a pile of notes and all of these learning materials, and really the core information was not really sticking, and you have to work hard as a student to figure this out. So how can we fix it? We fix it with a priority list. Imagine you're a young educator and your professor says, can you please teach this lecture? Don't worry, you don't have to establish everything from scratch. Here are the PowerPoint slides. And you get PowerPoint slides, maybe 80 PowerPoint slides, 80 for 90 minutes lecture. And then you go through these slides. You know beforehand what is the main goal of the lecture. Write it down, one sentence. What is the main goal, what the students should have learned after they leave the lecture hall? And then you mark all of the PowerPoint slides with a 1 that is information which is directly related to the learning goal. That's the priority. Now you will have marked probably 30 to 50% of the slides, max. So what about the rest? The rest is all nice to have. And to be honest, most of the rest of the nice to have, it's even rubbish. Rubbish in the sense of that it's just distracting. So go on with your prioritization and screen the rest of the slides for a number 2, which is interesting, nice to have, which helps you to guide to the priority slides, which is a side information that makes it easier to connect to students' everyday life or something like that. So that gets number 2 and it can stay in, and all of the rest you will kick it out. And you will see that your life will be much easier and the lecture will run much smoother. Mistake number 2 of the 5 most common teaching mistakes. It's explaining something without visuals or with the wrong visual. You know, students cannot see what's in your head when you explain it. They need to see it actually on the PowerPoint slide or you drawing on the whiteboard. That's, by the way, always an option. Having not the right visual is often the problem rather than having no visuals, because nowadays with all of the in the digital world and with all of the PowerPoint presentations, usually you have visuals for everything. Make sure that the visual you have really describes what you want to say. Often here also the visual explains much more than the core of what you want to do. So the fix here is pick the right visual, and if it's not available, draw it. Make it simple and keep it simple. A simple line diagram, a line schematic drawing, doesn't need to be pretty, sometimes helps much more than the most beautiful science art. This is especially true for models. If you teach, for example, DNA damage pathways, there are beautiful DNA damage pathways already in papers and in books. Be really aware that they contain a lot of information and it's all colorful and correct and beautiful. But if you just want to explain, for example, ubiquitination of a DNA repair protein, you don't need to have the whole DNA repair machinery and this one tiny protein just at the bottom of the schematic and then point there. Pick this out, enlarge it, or draw it yourself. Put an arrow, which enzyme puts the ubiquitination, for example, and so on and so forth. You get my point. So the fix is get clear with your visuals. The third common teaching mistake that really is a bad one, and it impacts learning very negatively, and the other way around, it helps learning tremendously in the classroom. The mistake is lack of understanding checks. So if you have the most beautiful lecture slides built around the core learning goal, beautiful visuals that are very fitting to what you want to explain, and you go on and on and on for 45 minutes or for 90 minutes, and you never check in between if what you said actually landed, you might lose the class. Could be that halfway through you lost them basically all because there was one thing where they just got stuck for whatever reason. So how to fix this mistake? You just need to ask a quick question. You can put the question on the PowerPoint slide. You can ask the question, say it slowly and repeat it. Give them time to think. Tell them to talk to their neighbors about what they think is the answer or what they have remembered from the input. And then collect information, 3 to 5 voices from the class to exchange. And then ask when one student reports something, do you agree? Yes, no, let them give a hand sign. There are a million of ways. The digital way, you can also put a quiz to the presentation where you give them a multiple choice option or where you let them put in an answer, which is a keyword maybe, and then you will have a word cloud to present. You have to do understanding checks. It helps immensely because then you understand what they understand. And that helps you to really continue the class and build on that. And you're never in the gray. You're never unsure. Did they get this? Why are they looking at me like that? You will know, because if the quiz results in the fact that, well, there was some misunderstanding or the students got it the other way around, or maybe they got another information from another class, so you have to ask them, oh, this indicates you were all the opinion that it's C rather than B, but let me tell you, in this case, the enzyme reacts like this, so we have a scenario here of feedback inhibition. So you can ask them, what makes you think it's C? Is there a reason for that? And then they might explain, oh, in another class they had this and that, but then you can explain that this is another version of enzyme which reacts differently. Whatever, I made this up, this example, but you see where I'm going to. A conversation is started between you and the students, and this helps to really have a lecture with impact. Mistake number 4 of 5 very common teaching mistakes. Not connecting what you're telling about science to real-world problems. Sometimes I still struggle with that because I love the science as is, and I'm sometimes honestly not interested in the bigger picture real-world issue. But here's the thing. I am 20 years ahead of my students, and the moment that I learned the basics in my studies, when I went to lectures, I needed those connections. And that's why we as educators should also give these connections to real-world problems to the students. When you add purpose to the classroom so that it's clear that this is not just enzyme kinetics, but it is directly related to how medication works, how much you can drink, and when you will feel sober again, how some diseases affect people more than others, dependent on this enzyme that is either present or not present. Whatever, you can figure out for everything a real world example and even a bigger picture real world problem with the health crisis, rising costs, people getting older. Is it maybe a neurodegenerative disease that is age related, that is connected to what you are teaching? and so on and so forth. You get my point. By connecting this core scientific learning snippet with the bigger picture, which is out there in the world, which somebody who's not studying could understand, diabetes, society getting older and older, rising health costs, that makes learning easy because you have a connection to something that you already have here in your brain, and then you connect it. So if you are a beginner educator, and was the same for me, I struggled to invent those, basically, or not invent, to come up with them. Or I couldn't decide, should I now take something medical, but I'm not a medical doctor, so I felt insecure. Use the internet. Just ask what problems are there connected to this, and search for these examples, and then you just pick one. It's an example for a connection to a real world problem. You don't have to explain everything. It's just connected. The core of your lecture remains enzyme kinetics, for example. Okay, now we have 4 common mistakes, and let's add a 5th common mistake in the classroom. It's not something like those before that has to do with slides, with selection of what you teach, how you check understanding, and so on and so forth. It is the lack of confidence in the classroom. Let me explain. It has to do with how you react to questions. Now, how you activate the students and make them ask more questions in the classroom, that's a different story. That's about building trust in the classroom. But let's say you are there already. The students trust you. You have established that communication belongs to learning. So asking questions is not only okay, it is appreciated and recommended. So the students will ask you questions, or the students will respond to your questions. And now, occasionally, the answer might be total rubbish. It might be just simply wrong. Now, how do you react? If it's really completely wrong, you can say this. I'm sorry to say, but it doesn't make even sense. Give an explanation, because in this special scenario, the enzyme has no XYZ, whatever, activity. If you say a strict, no, that's wrong, make sure that you do not blame the student and that the student doesn't lose face. You will figure out a way. Just imagine it's you answering very wrong, and what kind of answer would you want? You would definitely want the correction, or you would want that if it's said, that was wrong, sorry, but somebody else has an idea, and then student B, the next student, says the correct answer, you would involve student A again and say, do you agree with what B said? Does it make sense? And probably student A would say, relieved, yes, it totally makes sense. Now that I think of it this way, yeah, it makes sense. And that is how you build confidence, because student A had a thought that was not 100% correct. However, you gave student A the chance to then think along with the response of student B. And in general, encourage the class to speak out what they think, to share their thoughts, even if it's wrong. Actively build into the lecture, into the quizzes, into your communication with the classroom, questions where they are asked to speculate. And this is so important, because when you lack confidence in the classroom, you're missing so many opportunities to really interact with the students. And the students have also problems to allow their own thoughts and thinking room in the classroom. And they only wait until the right input is given from somewhere outside. But you, as an educator, you want them to generate the answers and to rely on their brains and on their neighbors' brains when they work in groups, and to really have trust into what they know. So the simple fix in 2 words is normalize struggle. There is nothing bad in being wrong in the class. You want the students to learn and understand, and being able to phrase a thought and then in the end also write down a thought, because in the exam they are probably asked to discuss ABC, explain ABC, explain why under these circumstances is not helpful. Things like that you can only do if you encourage them to work with their own thoughts, which might be sometimes not the right answer. Normalize struggle. So these were the 5 common mistakes in life science teaching and how to fix them. I hope this was helpful, and if it was, then leave a like, subscribe, and consider also checking back in for the next videos. I have a lot of didactics videos, and I hope you as a beginner educator look forward to your task to teach the next generation, because it's important and it's also a lot of fun. Happy teaching!